Hi, Miss Marion here. We are going to go Unit 5, Lesson 8. Turn back to page 189. Read the I can statements. I can explain in my own words how the graph of a linear function relates to its rate of change in individual value. And I can determine whether a function is increasing or decreasing based on whether its rate of change is positive or negative. Those are goals for today. So go ahead and write yourself a sentence, how you feel about it right now. Also, number 1, I don't remember. 2, I kind of remember. 3, I got it. And then 4, I can teach it to my friend. Let's turn back to page 67. Here we have some graphs. Diego said that these graphs are in order from smallest to largest. Mia said that they are in order from largest to small. But these graphs are not numbers. What do you think Diego and Mia are thinking? How would they know this information? So go ahead, pause, answer that question, and then come back to me. All right, so let's kind of look at it. Let's look at this first graph here. On this graph, we can think about it as, let's talk about our slope. Here, our slope is negative because it is going down the hill. So maybe that's why Diego was saying that they are in order because of the slope. Here, looking at the middle one, right, our slope is 0. And then the last one, our slope is positive because it's going up the hill. Another way we can actually look at it here is if we're looking at the y-intercepts. So our y-intercept is positive. Our middle one we still have a positive y-intercept. And then on this last graph down here, we have a negative y-intercept. So these are the ways that both Diego and Mia can actually look at these graphs to say as far as if they are in order, if they are not in order. So this is starting to get our brains kind of thinking about graphs and how they are, because today we're going to be talking a lot about graphs. All right, let's go ahead and turn to page 67 through 68. Here is number 1. Jada earns $7 per hour mowing her neighbor's lawn. Name 2 quantities in the situation that are in functional relationship. Which did you choose to be the independent, and also pretty much the dependent is the second question, where it's what is the variable that it depends on it. So independent, dependent. Write an equation for the representation of this function, and then here is a graph of the function. Label the axis and label at least 2 points with input and output pairs. So this is going to take a little bit, so go ahead and pause it, work through that, and then come back to me and see if we have done it correctly. All right, so we are talking about hours as far as Jada, how long she works, and then we're also talking about money that she received. So we have money, and then we have hours. So we need to figure out which ones are independent and which ones are dependent. I like to kind of figure out my dependent first, and then my other one is independent. So I like to say to myself, does hours depend on money, or does money depend on hours? And I'm going to say money, so I'm going to say this up here. So money depends on hours. So our money is going to be our dependent, which is our y, and hours is going to be our independent, which is our x. Okay, so now we can actually go ahead and label our stuff. So I'm going to say our bottom part is a time, right? And it is in hours. Our y-axis is our money. So it's, we'll just do it as money. Okay, and so we have our axis is labeled, and let's go ahead and kind of figure out our equation. Notice how the graph kind of starts at 0, 0, and so our equation itself is going to be y equals 7 multiplied by X because it's $7 per hour. So it's 7. So how does it change? Okay, it changes by 7 multiplied by X. And then we're also going to go ahead and do input and output functions kind of thing. So if I had 1, if I put input 1, well, let's actually do it up here. If I do 1, she makes $7. If I do 2, it's 14. Let's do 3. 3 times 7 is 21. So 1 is, so this point here is 1 comma 7. Let's do this one as 2 comma 14. And let's do this one as 3 comma 21. You didn't have to do 3 of them. I just did them, but at least 2 or more. And these are our inputs and our outputs. All right, here on page 68, here is number 2. It says to convert feet into yards, you multiply the number of feet by 1/3. Name 2 quantities in the situation that are a functional relationship. What do you do as your independent and dependent? Write an equation, and then also draw the graph. And then we have at least 2 points with the input-output pairs. Go ahead and pause, and then come back to me again. So let's go ahead and let's start with the 2 quantities. The first one, we're going to say that it's length, and it's in feet. And then we have our length, and it's going to be in yards. And because we're looking at it saying, okay, convert feet to yards, you'll multiply the number of feet by 1/3. So that's going to make it so that the yards is going to depend on the feet. So the feet is the independent. So independent. And then the yards is the dependent. So let's go ahead and label our stuff. So we're doing length in feet. And then we're also doing length. This is yards. So now we want to go ahead and write an equation. So I'm going to say we want to go ahead and we want to get our yards to equal. So we want to go ahead and make an equation to go ahead and figure out our yards, right? So I'm going to say as far as our equation, we're going to have the yards is going to equal 1/3 multiplied by our feet. So this is our equation that goes along with it. And then we want to figure out inputs and outputs, right? So we want to go ahead and we want to put in our feet length, and then we want to figure out our yard length. So I'm going to say 3. 3 is my feet. So I'm going to take 1/3 multiplied by 3, and I'm going to get 1. And then let's do 6. 6 is my feet. 6 multiplied by 1/3 is 2. And then let's also put in 9. So 9 multiplied by 1/3 is 3. You don't have to do 3 points. I did 3 points. So we're going to go over about 3. So let's kind of figure out what kind of line it's going to go. And a line is probably going to go something like this. It is going to go through 0, 0 because it is a proportional relationship. It is a proportional equation. So if we go over 3, it's going to be up 1. Over 6, it's going to be up 2, and about over 9 is going to be up 3. Right, so this is our input and our output for this situation where we're converting feet to yards. So the purpose for this activity is for us to go ahead and understand proportional relationships, and they are functions. It's where we can go ahead and write equations for the stuff that we have, right? And so, yeah, proportional relationships, they're functions. Functions pretty much a fancy way of saying that we can write an equation for a situation. All right, let's go ahead and turn to page 69. On page 69, we have that there are 4 tanks of water. The amount of water in gallons A in tank A is given by the equation A equals 200 plus 8T, where T is in minutes. The amount of water in gallons B in tank B, so that should be tank B, starts at 400 gallons and is decreasing at 5 minutes per gallon. And so for number 1, we're going to ask which tank started out with more water. And then number 2, write an equation representing the relationship between B and T. And then number 3, one tank is filled up, the other is running out. Which one is? How can you tell? And number 4, the amount of water in gallons for C. Tank C is given by the function C equals 800 minus 17. Is it filling up or draining out? How can you tell for that? Okay, so go ahead, go through all these equations, go ahead and answer those. And then once, so pause and answer it, right? And then once you're done, go ahead and come back to me. All right, so number 1 is asking, we're relating between tank A and tank B. So tank A, remember, is the A equals 200 plus 8T. Tank B starts at 400 gallons and is decreasing 8 gallons per minute. So we want to go ahead and we want to figure out which one has more. Tank B starts with 400. And then remember, tank A starts with 200. So this would be tank, the answer would be, go ahead and be tank B. Actually, you know what? I'm going to put that in blue. So tank B. Writing an equation representing the relationship between B and T. So I'm going to kind of follow the format as far as with the tank A. So we're going to say B equals, and then where does this tank start? It starts with 400 gallons. And then what happens with it? It is decreasing at 5 gallons per minute. Decreasing means to go down. So kind of subtract, and then we have 5, and then minutes, gallons per minute. Do we know our minutes right now? I don't. So I'm going to put T as for our time frame. One tank is filling up, the other one is draining out. Which one is which, and how can we tell? Well, tank B, it told us it is decreasing. So B, it is draining out because it's decreasing. Tank A is increasing. How can we figure out that it is, so it's increasing or filling up? And how do I know that? I'm going to look at the equation again. We have A equals 200 plus 8T. Reason why how I know it's filling up is because it is positive 8T. And then we have tank C. C equals 800 minus 7T. Is it filling up or draining out? How can we tell? By just looking at the equation. I am going to say that it is draining out. How do I know? Oh, that's more of exclamation mark, okay? How do I know? Well, it's because it's subtract 7T. All right, here is number 5. So there are 4 tanks, right? We have A, we have B. We were looking at C, and now we have this. The graph of the function and the amount of water in gallons D is tank D at the same time as shown, okay? Is this filling out or filling up or draining out? How do we know? Go ahead and pause, answer that question, and then come back to me. So tank D is this equation here, right? So tank D, what is it doing? It is draining out. How do I know it's draining out? This graph is going down the hill. If we read it from left to right, it's going down the hill. That's how we know it is draining outward. All right, let's go ahead and turn to page 71. On page 71, Noah is depositing money into his account every week to save money. The graph shows the amount he has saved as a function of time since he opened his account. Elena opened the account at the same day as Noah. The amount of her money, E, in her account is given by the function E equals 8W plus 60, where W is the weeks since the account was opened. So what you're going to do is you're going to compare the two, the graph and then the equation. So one, who started out with more money in their account? How do you know? Who is saving more money at a faster rate? Explain how you know that. And how much will Noah save over the course of a year if he does not take any withdrawals? And then how long it will take Elena to save that much? Okay, go ahead and answer those questions. So pause and answer those questions, and then come back to me. All right, let's go ahead and go through it. The graph is Noah. So let's look at the graph. So the graph is kind of where the Dots actually start. So where does this start? It starts at 60. And then Elena, where does she start? Well, she also starts at 60. So they are the same. Let's look at number 2. Who is saving more money at a faster rate? So let's for Noah, we have to do a slope triangle. So we have to see how far it actually goes up. So notice how it goes on the side. It goes from 80 to 100. We only did part of that. So that's going to be half of it. So it's going to be 10. And then we are going over 2 spots. How much is 2 spots? That is 2. So we have 10 over 2, which is Noah, which is the same as 5 or 5 over 1. So Noah, he increases his amount by 5. Let's figure out what Elena does. Elena is, remember, that's how does it change as far as the equation itself? That's going to be next to the W, which is number of weeks. So Elena, she has 8. So who is saving the faster rate? That is Elena. And then how much will Noah save over the course of 1 year? So let's kind of think about it itself. We have it where there are 52 weeks in 1 year, right? And so Noah is going to save, so I'm going to kind of write it off to the side. So Noah is going to save $260 over the amount of a year. So he has 60 to open, and then it's $10 for every 2 weeks. Okay, so that's kind of how this goes here. So $10 for every 2 weeks or 5 for every 1. If we take the 5 and multiply it by the 52, we get the 260. That's how much he's actually putting into his account. Let's go ahead and figure out for Elena how long will it take her to do the same amount for Elena. So we're going to have to go up to 260. And remember, we're going to take that 260 and we're going to divide it by how much she has per week. And so her amount as far as solving per week is 8. Right? So if I do 260 divided by 8 is 32. Let's actually write that down correctly. So 32.50. But are we talking about weeks? Can we have half a week? No. So it's going to take her 33 weeks to go ahead and have that same amount, which is $260. So for today, we are looking at just looking at linear functions. We're looking at functions, equations, and how they change, how they not change. So we're looking at both an equation and also a graph. Remember that a function is the same thing as an equation, right? How we can tell from a graph if the initial value of the function is positive or negative. Remember, that's the vertical axis on the number on the vertical axis, which is the vertical intercept. So kind of keep all of these things in mind, that all we're doing is kind of comparing a lot of different things together. Go ahead and go back to page 189. Go ahead and read the 2 I can statements. I can explain in my own words how the graph of a linear function relates to its rate of change and initial value. Remember, rate of change is our slope. Initial value is our y-intercept, or kind of where it starts. And then I can determine whether a function is increasing or decreasing based on whether its rate of change or the slope is positive or negative. Go ahead and write yourself a sentence. Give yourself a number. So 1, I'm still confused. 2, I kind of got it. 3, I did get it. And then 4, I can teach it to my friend. And so remember, we are doing practice problems for today. Make sure you get it into Canvas and go ahead and do those. And have a great day. Bye.